Hi, my name is Dr. Karen Lythgoe and I'm a seismologist at the Earth Observatory of Singapore at NTU, where I monitor and study earthquake hazards and subsurface imaging, both for the deep Earth and the shallow Earth. Recently, there was an interesting article in The Guardian about how a group of geologists in New Zealand are hoping to tap into a clean energy source by drilling deep into an extinct 11 million year old volcano beneath the city of Dunedin in South Island, New Zealand. So they hope to harness the energy that's stored in these old volcanic rocks for geothermal heating of homes. So their idea is to pump water underground, and then that water will get heated by the residual heat within the rocks, and then that will come back up to the surface and flow through buildings. So they're planning on drilling 2 wells in order to gather enough data to be able to test whether there's sufficient heat at depth below the surface in order to power a geothermal power plant. It's an interesting proposition since there's so much geothermal energy in our region in Southeast Asia, where over 90% of the world's volcanoes sit. And knowing what's happening under the earth where these volcanoes sit is not only crucial to future energy resources, but also to the health and safety of all people in the region. And we don't just find geothermal energy at volcanoes, we also find it along geological fault lines. So these are zones of weakness within the Earth's crust, and so that means that they can act as pathways for fluids to circulate. So one example of this is the Great Sumatran Fault, which we're currently monitoring for earthquake hazards, but it also has hot springs along it in some places. So potentially we can use seismic imaging not only to see where the earthquakes are and to understand it from a seismic hazard point of view, but also to understand the geological system as a whole. In addition to heat, to build a geothermal power plant, you also need to have good water flow. And this is really critical so that a large amount of water can be pumped underground and then come back up to the surface. So this means that the rock must have some fractures in it. So old volcanoes might not be the best place for this because they may not have many fractures, but of course geological fault lines are places where water should flow. However, if you do harness the energy from the earth by a geothermal power plant, you have to be very cautious to monitor the fracture zones that are being drilled, since there is the potential for small magnitude earthquakes to be triggered. One extreme example of this is a few years ago in South Korea, where a magnitude 5.5 earthquake actually happened close to a geothermal power plant. So it's thought that this magnitude 5.5 earthquake actually happened on a geological fault that was nearby and was previously unidentified. So this shows why the work that we do at EOS in terms of identifying geological faults and monitoring seismicity is really vital. So geothermal energy is a complex system. We need to have a heat source, and you also need to have fractures in the rock in order to have good water flow. And of course, you need to establish seismic monitoring. Here in Singapore, we have some hot springs, and in the future, there's a plan to drill about 2 kilometers below the surface in order to test how hot the water is and how fast it would flow at these depths. So we expect the rocks to have some fractures, but we don't know if there will be enough in order for the water to flow. So it's going to be really interesting and really exciting to see whether geothermal energy could be a future energy resource here in Singapore. We know in the rest of Southeast Asia that there is tremendous potential for geothermal energy, with something like 40% of the world's estimated geothermal energy reserves being in Indonesia alone. But we do need to carefully consider and monitor these areas for seismicity. And that's the same as other seismically active areas, such as New Zealand. So the work that we do at EOS and the monitoring that we do in the region is vital in order to help governments and communities plan for future development to ensure the safety and the prosperity of all people in Southeast Asia. And we also need to play a role in the energy transition. And one part of that is understanding where and how we can safely harness Earth's heat in the future. And to do that, we need to understand the geological systems as a whole. So we're working with many countries across the region in order to increase their knowledge base and to assist them with a better understanding of what is happening deep underground beneath the Earth's surface.